Hello and welcome to the Network Professor, a series of podcasts hosted by me, Glyn Jones, Product Manager at Hughes Europe. Hello and welcome to the next in the series of podcasts in brief, brought to you by me, Glyn Jones, Product Manager at Hughes Europe. I was at my parents' house last weekend and I was showing my kids pictures of me when I was much younger, and we were discussing what was in fashion back then. They were mightily impressed by my flares. Think back to the 70s, or if you weren't there, look at some images of flares from the 70s. They were big. Move on another decade and another fashion trend was long white socks. These fashion trends eventually fade, but with the odd exceptions, they will resurrect themselves years later. Long white socks being a case in point. And the current generation believe that they created the trend. Networking trends can follow very similar patterns. There'll be a solution to solve a current problem, technology will move on, and the way things are done will change. The original solution won't now solve the problems, and it becomes yesterday's solution. A new solution is created to solve the new problem, and it becomes the latest and greatest way to do things. Technology and the way we do things then changes again. And we find that the way we did things originally, but with a modern spin on it, now fixes the problem. So we rename it something else so it looks different, and we have created a new technology. A good case in point is mainframe computing. Back in the 60s and 70s, you used to have a large computer hall with massive computers in it, which you would then access from a dumb terminal to carry out your computing requirements. Does this sound familiar? With the advent of PCs, as we moved into the 80s and 90s, the computing power moved out to the desktop, and there was less of a need for these large, antiquated mainframes. As we moved into the 21st century, with the development of the internet, there were some large companies, Amazon, Google, Microsoft, who had large banks of powerful computers in data centers, which weren't always being used to their full capacity. I have an idea, they said. Why don't we take this spare capacity and monetize it, and sell it to other people? And let's call it the public cloud. I know I'm glossing over the whole cloud story slightly, but that is fundamentally how cloud computing became what it is today. Think about it though. Other than the fact that it uses modern technology, how is cloud computing really any different to the mainframe computing of the 60s and 70s, other than being known by a different name? Mainframe computing, a large number of big computers in a computer hall used as a shared resource. Cloud computing, a large number of big computers in a data center used as a shared resource. See, old concept using new technology created by the current generation. No different to fashions. And that is where we are today. Large banks of servers and storage arrays providing many of the services that we use in our day-to-day lives, whether for business or personal usage. What this does mean is that there is a lot of critical data going backwards and forwards between where it is needed and where it is stored. Now, imagine a scenario where your critical business data doesn't have to embark on a long journey to a distant data center only to trudge back with the insights you urgently need. This concept is the promise of edge computing, a shift that brings data processing right to the doorstep where the action happens, significantly slashing response times and boosting operational efficiency. In today's podcast, we're exploring the rise of edge computing and its impact on network infrastructure. Getting to grips with this emerging technology isn't just an academic exercise, it's a crucial discovery exercise for businesses, especially those operating across various locations. So, let's get a brief understanding of edge computing and its benefits. At a fundamental level, edge computing is like having a mini data center right at your fingertips, wherever and whenever you need it. It's a tech strategy or framework that decentralizes data processing, moving it closer to the location of data generation rather than relying on a central data center which could be miles away. Without needing to take a round trip to this distant server, your data can be processed faster, enabling quicker responses and smarter local decision making. Going back to the late 1990s, the emergence of cloud computing transformed the way we stored and shared digital information and resources between multiple users. In the early 2000s, the introduction of software as a service platforms prompted further progress, allowing applications to be provided over the internet. From here, the use of cloud computing began to soar as AWS, Microsoft Azure, and Google Cloud Services launched. The rise of edge computing marks another significant evolution. While cloud computing altered how we store and access data, Edge computing takes this a step further by minimizing the distance data travels, thereby reducing latency and speeding up the whole process. The benefits of edge computing are substantial. Reduced latency means your operations can leverage real-time data analysis, something that becomes increasingly critical in our time-poor daily lives. Then there are the improvements in cost efficiency. By processing data locally and reducing the burden on central servers, businesses can see significant savings on bandwidth and data storage costs. Ultimately, with these advantages, edge computing paves the way for more efficient and agile operations. Edge computing is rapidly becoming less of a buzzword, more of a central strategy for businesses across many industries. Its adoption is driven by the need for faster data processing and the desire to leverage real-time insights for decision making. Let's take a closer look at where edge computing is making waves. Construction. Imagine sensors at a construction site that immediately flag safety hazards or efficiency bottlenecks. That's edge computing at work. Healthcare. In hospitals, it's enabling doctors to make quicker life-saving decisions with real-time patient data at their fingertips. Retail. For retailers, edge computing can help transform shopping experiences with personalized offers the moment you walk into the store, thanks to instant data crunching. Energy. In the energy sector, it enables real-time monitoring and management of infrastructure, enhancing energy distribution and consumption. As edge computing becomes increasingly prevalent, it's clear that our network infrastructures must undergo significant changes to keep pace. This shift demands networks that are not only more efficient and faster, but also more secure and adaptable than ever before. Here are some points to consider when adopting edge computing for your business. Firstly, decentralization's double edge. While moving data processing closer to the source improves bandwidth efficiency and accelerates decision making, it also complicates how we manage communication and security. Distributed processing means data is traversing a more complex web of connections, requiring networks to be more vigilant and adaptive to safeguard against potential vulnerabilities and ensure seamless data flow. Security and compliance. Introducing more devices into the network makes this attack surface wider, increasing the potential for security breaches. Additionally, ensuring compliance with data sovereignty and privacy laws becomes more complicated as data processing spreads out geographically. Scalability and flexibility. Networks must be designed for scalability and flexibility to accommodate the growing number of edge devices. They need to easily expand and adapt without compromising performance or security. Resilience and continuity. A resilient network infrastructure with effective failover options is critical to minimizing downtime. As we become more accustomed to the instantaneous advantages of edge computing, even brief interruptions can significantly impact operations. For edge computing to fulfill its potential, we must ensure our network infrastructure evolves to be stronger, smarter, and more adaptable. It must be ready to support the dynamic demands edge computing brings to support seamless, secure, and efficient operations. Adopting edge computing for your business will bring its challenges, from ensuring robust security to seamless network management. But these can be overcome by looking at the following things. Selecting and deploying solutions for tailored connectivity and network management such as SD-WAN and SASE that enhance the scalability and flexibility needed for edge computing. Designing and implementing appropriate security protocols for the edge environment and simplifying compliance and regulatory obligations. Bolstering network reliability with strategies like redundant systems and automated failovers to minimize downtime and keep your operations running smoothly. Having network services that can operate 24/7 with full support and forward-thinking updates to keep your business ahead of the curve. As the adoption of edge computing accelerates, we see a future where this cloud framework isn't just an option, but an integral part of operations. As industries continue to embrace digital transformation, edge computing will likely be a catalyst for driving efficiencies. Pairing with other emerging technologies such as IoT, AI, and machine learning, edge computing will further push the boundaries of what's possible with instant data analysis and decision making. Embracing this network shift with the right partner will ensure your network is primed for the agility, security, and efficiency needed for your business to remain competitive. The next podcast, The Challenges of Network Scaling in Growing Business, will be out next Thursday. Do subscribe or follow me on your podcast platform of choice to be notified when it comes out. Thank you for listening and do enjoy the rest of your day.